Welcome to myclass.com. In this lesson, we are discussing about merge sort algorithm and its analysis. Let's start. Merge sort. Merge sort is not like our bubble sort or insertion sort or selection sort. It is little different from those sorting operations. So let's discuss about our merge sort algorithm. Merge sort uses a divide and conquer approach. We are doing like if this is our problem or this is our list to sort, we want to divide it into different parts, then doing some operations and we are combining back this lists and achieving a sorted list. That is a concept of merge sort. It is a divide and conquer approach. Also a stable algorithm. Stable means if the same elements are there, like 225s are there in the sorted list also, that 25s are in the same order that was in the original array. Okay, so that is the stable algorithm. The next is, it is a not in place algorithm. What is not in place algorithm? The merge sort requires lots of extra memory for sorting purpose. Variable memory that is related to number of elements that we want to sort may be equal to that memory for the list, or extra memory is needed for sorting purpose. Because of that, merge sort is a not in place algorithm. Then the time complexity of merge sort is order of n log n. All, best, worst, and also average time complexities are order of n log n. We know that merge sort is a not in place algorithm. It requires memory related to number of elements in the list. Because of that, the space complexity of the merge sort is order of n. Now we want to discuss about how we can achieve order of n log n time complexity and the space complexity order of n. Before that, I am explaining how merge sort is working. Please look at this is 8 elements. For that, we are dividing this 8 element into 2 parts. Then we are dividing this into another list, 4 list with 2 elements. Then we are again dividing with all the partition up to 1 elements. Here the one list contains only 1 element. All lists contains only 1 element. Then after that, we are starting sorting and merging. Up to here only division is taking place. Okay, this is the overall view. The method of working the division and the combining and the sorting, that is different. You can understand after the explanation of algorithm. Now after this is the overview of a merge sort working. Now we are combining this two and will get here, then this two will get here, this two like that. After that, this 4 elements are this 4 lists are in sorted order. So we want to combine this sorted array into a sorted array. So we will get like this. After that, we are combining and merging this two and we will get this. That is the working of a merge sort. So in merge sort, the two processes are the dividing the list into up to all the partitions contain 1 element. After that, we are combining these elements, because this all list, when look at this level, this all list containing the elements that all sorted, because only 1 element is there, so that is sorted only, is it? So after that, we are merging adjacent sorted sublist into another list. Okay, like that the merge sort is working. So for merge sort, a very important process, the time consuming process is merging two sorted array into another sorted array. So let's see, these two are 2 sorted arrays. So we are merging this sorted array into another sorted array. That is a time consuming process in terms of merge sort. So we are first discussing that process. So merging 2 sorted array. So this algorithm is for merging 2 sorted arrays. L is the left sublist and R is the right sublist and A is the resultant sublist. So this is our left sublist and this is our right sublist. So first we are finding the length of left array. So LL is the length and LR is the length of R sublist. Okay, so here LL is, so in this example LL is equal to 4 and LR is equal to 3. Now we are initializing 3 pointers. I is for our left array and J is for our right and K is for our resultant array. Now first I is pointing, so all the pointers are first pointing to 0th index. Now we are starting a loop, that is I less than LL and J less than LR. We are checking the values. And we all know that this left sublist and right sublist are sorted. So we want to check from first index to the last index. So our algorithm is starting like first I equal to 0. Okay. So we are checking if L of I is less than or equal to R of J. In the first element of L R, which one is smallest? That we are checking. If Li is smaller, we are adding this element to our resultant array. In this case, our 10 is bigger than 7. So this else part is working. In the else part, A of K, we are assigning R of J into A of K. J equal to 0 at this moment. So we are assigning 7 to here. Okay. Here we are assigning the value from the R sublet. So we are incrementing J to 1 and also we are incrementing K to 1 because we already inserted one value to our array A. Now again we are checking. Here also I less than LL because I equal to 0 and J equal to 1. Both conditions are correct. Again checking L of I is less than or equal to R of J. Here L of I is 10 and R of J is 12. 10 is less than 12. So true. It's now the turn to add 10 to our array. L of I to A of K. So 10 will be inserted here. After that we are incrementing K value and also incrementing, at this moment we are incrementing I value. I equal to I plus 1. Next we are checking again. Here also I is less than 4. I is less than 4 and also J is less than 3. So we are again checking L of I. 14 is less than or equal to R of J. R of J is 12 now. 14 is not less than 12. So we are inserting 12 now. Else part is working. So we are incrementing J. J equal to, okay, now the J equal to 2. When J equal to 2, 2 is also less than 3 and also I equal to 1. 1 is also less than 4. So we are checking again. 14 is less than 23. Yes. So now the turn of 14. 14 will be inserted here. Okay. 14 will be inserted here and I will be incremented. Now it's a term for 25 is less than 23. Now K is 4. Now I equal to 2 and J equal to 2. Here also I is less than 4 and J is less than 3. Again this while loop working. L of I 25 is less than R of J 23. No. So this else part is working. So 23 will be here and we are incrementing K value and also J value. Now J equal to 3. So at that time, after the insertion of all the elements in any one of the list, the while loop should not work because I is less than LL now because I is 2, 2 less than 4, but J is 3, 3 not less than 3. So this is not going to be work. At that time, for inserting the remaining values from the any other list, we are doing this while loop. So we are checking I is less than LL. Yes, here I is less than LL. 2 is less than. Some remaining values are to be inserted to our resultant array. For that, this while loop is A of K is equal to L of J. So the L of I is 25 years. Now we are incrementing K value and also I value. Now I equal to 3. So 34 is here. Now the I value become 4. 4 is not less than 4. So it is not going to work and it is definitely it is not going to work because J is already 3. So 3 is not less than 3. Okay, like that we are merging two sorted array into another sorted array. This is the time consuming work in the case of merge sort. After dividing all the array elements up to the list containing only one element, we are started merging two sorted array into another sorted array. Okay, now we will discuss our merge sort. So merge sort is a recursive algorithm. Recursive algorithm. What is recursive? Recursive means this procedure is inside this procedure itself. We are calling this procedure. See, merge sort. Merge sort is two times merge sort is calling inside this same merge sort. That is a recursive procedure, recursive algorithm. Here is our merge part. So two sorted array, merging two sorted list into another sorted list. So let's start how merge sort is working. So our merge sort algorithm is starting with, we are checking the length of our input array, and if the length is less than 2, that is our base condition. There should be a base condition for recursive algorithm, because we are calling again and again and again, but we want to return back. For that there is a base condition. There should be a base condition. That base condition is, we are dividing the list up to each partition containing only one element. That is, we are checking. If n less than 2, we are returned back to our previous stage. So in the else part, all working is there. So what is inside the else part? In the else part, we are finding a mid value. We want to divide the elements. We want to divide the list or array. So for that, we want to find a mid value. So our mid equal to n by 2. So in this case, our first mid is 8 by 2, 4. So we are now making two arrays, left and right, up how much elements? First left array is with 4 elements, and second array is up to n minus 4, 8 minus 4, here also 4 elements. So we are making two arrays left and right with 4 elements. After that, we are assigning first 4 value to our left array and then second 4 value to our right array. That is this step. For I equal to 0 to mid minus 1, left of I equal to a of I, for I equal to mid to n minus 1. Up to mid is 4, now mid to n minus 1 we are doing here. We are assigning value to our right array. So up to here we will get like this. See, the first calling of merge sort array, we get one left array and one right array. Okay, with 4 elements. So now we have reached here. After that, we want to recursively call the merge sort itself for left array and also right array. But when we are here, we are returned back to our merge. Our control is returned back to here. So this right merge sort calling is pending here. Okay, and also after the left right merging of this place also pending here. Okay, one right and one merging is pending here. Now we are concentrating on the left side, because this call is going to be worked now. So our A is our left array now with, so our NS length of A is 4 now. So our mid value is 4 by 2. Our mid is now 2 now. 2. Okay, so 4 is not less than 2, so it is going to execute. So mid is 4 by 2, 2. We are making two arrays left and right again with 2 elements. Okay, here 2 and 4 minus 2, 2. Now we are assigning these 4 elements to our sub array. So now we have reached here. Okay, like that. So in this call also there is this is our second call of left merge sort. Okay, so for this in the second call, when we have reached here, the control go to this side. At that time again one right merge sort right and our this level of merging also pending here. Okay, remember that. Now we are concentrating on this. So after that, when merge sort left, again we are calling. After we have reached here, this condition is like this. Is it? Now again in this third step also, when we are going to this side, our first one right merge sort calling and this merging also, level of merging also pending here. Remember, after that we have reached here, is it? So after, when we are reaching here, this base condition should be true. See, 1 is, here the length is 1, length of A, so n is 1, now 1 is less than so at that time it is not going to execute. But before that we have, there are pendings are there, so we are concentrating on that previous cases. So there is a write, merge sort write pending is there, so we are calling this now. Okay, so this is going to execute now. So for we are going to, when this is executing, the length is 1, so 1 is less than 2. Again, this is, again this else part is not working, but one thing is there, we have one remaining pending work, that is merging. See, so this merge left right A should be working now. Okay, so at that time this 2 merging will takes place and we will get like 14 and 34. Okay, now this all is clear. Third time the main calling is all completed, but this time this write and merge is pending here, is it? So we are going to work that. So we are going to the right part. So this write is going to work merge sort right. So we are dividing this to, base condition should work. So again this merge sort, see. So again we are here, left is base condition, so we have reached here also the base condition should work. So this, after this too, the merging should be takes place here, so the merging work. So after merging, okay, so after merging our list is like this now. So 10 should be here and 25 should be here. Okay, so this level of all working have finished. Now this also we finished, but this M is now remaining. Okay, so this left part full finish and this right part full finish. Now this is at that level, this merge is pending, so we are going to work that merge. Okay, so at that time this merging, so merging this 2 sorted array will work and we will get this left array should be in a sorted order. Okay, so now this level we have finished. But now we are going by, because after that this left part, so in the first calling of merge sort A, the left is all finished, recursive call also finished. Now we are going to that merge sort right process. So in that the same thing going to be happened. We are dividing this to what I am not explaining detail, because the same way it is also working. Now we are doing like this first, and now this one, and after that we will get this 2 sorted arrays, and then this array should be in a sorted order. So this is the first case of our, so this we have reached the first calling of our merge sort, is it? So this left is also in a sorted order and this right is also in a sorted order. After that, this is the pending merge sort. Here we have, there is a merge left right A is pending. So now this is going to happen and we will get the result like this. Okay, that is the working of our merge sort. Hope it is clear. Now we want to analyze our merge sort analysis. Let's generalize our condition. Here our n equal to 8. Okay, so when the whole process, the main process is, this is only for dividing and assigning values. The main process of sorting is taking place at merge left right A. So these 3 levels are the main working place. So see, in this first level, how many numbers we are sorting? In this 2 numbers are we are sorting. Here also 2 numbers, here also 2 numbers, here also 2 numbers. So total 8 numbers. That is n we are working on n elements. So in this level, in the second level also 1 2 3 4 1 2 3 4. See, in the second level we are sorting this 4 elements and we are getting this sorted array. Here also 4. So 4 plus 4, here also 8. So n times in this level also we are working. In this level also we are working n times. Is it? So each level we are working n times. N times we are working. Okay. So n times means according to the n value, that much of times we will require for merge sort. Okay. Then how many levels are there in the merge sort? In this particular case, when n equal to 8, how many levels are there? 1, 2, 3. 3 levels are there. So 8 and 3. What is the connection with the 8 and 3? You can write like this as a 2 raised to 3. 8 is 2 raised to 3. So there is a connection. That is the log connection. So we can write like that 8 is, see, 3 equal to log 8. That is log 2 to base 2, log to base 2. So that is 3. So we can equalize like this. So there is a log. So how can we find the number of levels in the merge sort? That is, when n is the total number of elements, then there should be log n levels. So each levels n times amount of times will be consumed. So like that. So in each level n times is there and total log n times log n levels are there, then the time complexity of merge sort is n log n. Okay, so for merge sort, the best, worst and average. Best, worst and average all are order of log n. Okay. Now I think you can understood how we can get the n log n time complexity for merge sort. Now let's see how much spaces we are using extra. See, in each level we are making space for n elements. See, so we can easily say that this is order of n space complexity, because our space required more is related to our number of elements n. So we can say that the space complexity of merge sort is order of n. Clear? So that is the working and analysis of merge sort algorithm. Hope it is clear now. Any doubt you can ask through comment. Thank you.